What you have is a air purifier that builds more of itself the more pollutant it absorbs.
Hey everyone, today I'm here at the Seed, Neoplants HQ, with our co-founder Patrick, and we're going to talk about the science behind Neopx, the first bioengineered air purifier for the home. Welcome, Patrick.
Thank you very much. I'm very happy to be sitting here with you.
Great to speak to you today. So my first question, what is this?
It's a beautifully designed sachet.
Okay, but what's inside?
So if you consider our product as a car, this is actually the engine. This is what drives the air purification performance of Neopx. We call them power drops. It's a powder that contains billions of tiny air purifying microorganisms. If you open the packet, you'll see what I'm talking about. When you mix this powder with water and then pour it on the soil of Neopx, these bacteria will start colonizing the soil, the roots of the plant, and the plant itself. And then they will start eating the pollutants that are in the air around it.
Okay, and when you say eating the pollutants, where do these pollutants go?
I literally mean eating them. Like when you eat a croissant, the croissant doesn't go anywhere. Its atoms are incorporated inside your body, your skin cell, blood vessels, muscles. In the same way, bacteria, when they eat the pollutants, they integrate the atoms that compose these pollutants, these volatile organic compounds, or VOCs, inside the bacteria's metabolism. So this way, the bacteria builds more of itself using the pollutants they target. So at the end of the day, what you have is an air purifier that builds more of itself the more pollutant it absorbs.
So what you're saying is this is a kind of magic potion for my plant. But where did you find this bacteria?
Yeah, there's this very famous quote from sci-fi writer Arthur C. Clarke that goes, "Any sufficiently advanced technology is indistinguishable from magic." And the most powerful technology in the world, by far, without comparison, is nature. Nature is a research experiment that's been going on in every single life form on this planet for the past 4 billion years. And with simple rules, the simple rules of evolution, you get something that is so complex, so elegant, so powerful, that nature really does seem like magic sometimes. And this is where the bacteria come from nature. More specifically, the bacteria that are in the power drops, like Pseudomonas putida, were isolated from very polluted area in the world, where they had to evolve the capacity to use benzene as a source of food to grow and thrive.
So basically, you just found this bacteria out there in nature and you just packaged it up?
Well, at first, this is exactly what we did. But it turns out that if you use bacteria that come directly from nature, even if they have the capacity to use benzene as a source of carbon, they don't do it efficiently enough to have a measurable impact on the air quality of an entire room. So what we had to do is to give nature a little boost and evolve these bacteria even further. The thing is, as humble humans, we don't have millions of years to do that, right? So this is where science and R&D comes in. The bacteria that you have inside the power drops have undergone 4 years of artificial or lab-assisted directed evolution. What that means is that these bacteria have overcome a series of challenges that they have to go through in order to increase their capacity to use VOCs as a source of food.
Sounds a bit like a boot camp for bacteria. I have a hard time seeing how this works exactly.
First, you put the bacteria in an environment that's polluted just above the level that they normally tolerate. So let's say they tolerate a concentration of 10, you put them at 10.5. Second, you isolate the bacteria that have survived this growth. Most of them will die due to random mutation, but some will survive. Third, you take these surviving bacteria and put them at a concentration of 11. And you repeat this process again and again until you multiply the air purification capacity of the bacteria, simply through evolution and a bit of human ingenuity.
Okay, so you hack the bacteria to boost its capacity to clean the air, and then you put it in the soil. How long does it live in there?
Yeah, it's a good question. When we take samples out of Neopx and we search for the bacteria, we actually find it even after 6 months post-inoculation. And we think it's actually much longer. We just stopped sampling at that point. That being said, even if you find the bacteria, the total population goes down. What we found is, depending on the conditions where they're in, it usually goes down after a month or so.
So I guess this is why you have to top up the power drops every month. But is this really necessary, or is it a commercial play?
Yeah, unfortunately, it's not really a commercial play. The lifespan of the microbiome is something we've been working on heavily, and we're very happy to have reached a month of lifespan for now. That being said, we're still working on the formulation of the power drops, and we hope to have something that lasts for longer in future iterations. Our goal here is really to have maximum impact on the environment by harnessing nature and creating products that people love.
So if the bacteria is doing all the work, why do I need a plant?
The plant actually provides an ecological niche for the bacteria. That's what's called a plant microbiome. No plants and the population of bacteria won't be as stable and won't be as performant. If you go back to our car analogy, you can have the most powerful engine you want, but if you don't have the rest of the car, you won't go anywhere. We've chosen this specific plant, pothos, because it's very robust, it's very well known, and we've actually developed the power drop specifically for that species.
So what I understood is there's a kind of symbiosis between the plant and the microbiome. But how do I know it's actually working?
Performance measurement has been the most surprisingly difficult work stream we had to work on. We focused a lot of R&D on it with the fantastic talents and experts in indoor air quality, and we're constantly improving. The biggest challenge is that commercial indoor air quality monitors track total VOCs, but they don't track specifically the harmful ones. And since our power drops specifically target the harmful VOCs, you don't have good readings. You need highly sophisticated analytical chemistry machines to study that. What we did is we actually hooked these machines to chambers through which we pass polluted air, and we put a plant or power drop inside. And with this, we're able to track the decrease of pollution over time and calculate a metric that's called CADR, or Clean Air Delivery Rate. We've done this both internally and with a third-party university that have expertise in indoor air quality. These tests show that our product have a CADR that's up to 30 times higher than any regular plant we tested. Based on this metric, we've been able to calculate that our product will have an impact in a room that's the typical size of a bedroom, so 160 square feet.
That all sounds really cool. I just had one last question. Can you also work on the plant itself?
Definitely. Actually, most of our team is working on the plant itself, and it's been an entire journey that I'd love to deep dive into.
That sounds fascinating. We're kind of running a bit short on time, but let's talk about this in the next video.
Yeah, for sure.
Thanks for your time today, Patrick.
My pleasure.
It was really interesting, and I hope you also found it informative. If you have any questions at all, just drop them below and we'll answer them in our next video.
See you soon.
See you.